Hello guys, welcome back to my channel, and in today's we are going to start with HCF and LCM using prime factorization method. So let's begin. Now let's take an example. Example is HCF and LCM of 12 and 14. Okay, so now the basic way to do this is drawing a prime factorization table here like this that you have already learned in your previous classes for 12 and for 14. Now you can also do this together, but I prefer doing it separately so it creates less confusion. So 2, 6, 3 and 3 ones are okay. 2 sevens are, sorry, this will be 7 ones are. So now we are going to write here prime factors, prime factors of 12 and 14 are. Okay, also in your exams you need to describe each and everything so they can give you marks on that. Okay, so if you have found out the prime factors, then you have to write it like that. Prime factors of 12 and 14 are. So 12 is equal to 2 into 2 into 3 and 14 is equal to 2 into 7. Now, in order to for you to find HCF and LCM, you need to know what is HCF. Okay, HCF is highest common factor. Right, highest common factor, and LCM is lowest common factor. Okay, now there's a short trick that you need to remember, so this will simplify things really easy. Okay, so HCF means highest common factor, so we think that highest power should be HCF. No, for HCF I will do it with a red pen. For HCF, choose minimum power, minimum power, and for LCM, highest power, highest power. Okay, so now for HCF, you need to see which term has occurred most number of times. So here, if we look at the prime factors of 12 and 14, 2 is common. Then is there anything else common? No. So HCF is only 2. Okay, now LCM. Now you need to remember while taking LCM, okay, while taking LCM, you need to see which prime factor has the highest power. Suppose we have 12 over here, right? 12 over here. So 12 has how many 2's? 2 times. Well, that means 2 square. So in the LCM, you will take 2 square. And then you will take 3 and then 7. Okay, like this you have to do. Suppose I have given another number like 16, for example. So 2 into 2 into 2 into 2. 2 2's are 4, 2 2's are 4, and then multiplied will be 16. How many 2's are here? 4. So the highest, sorry, if you're finding the LCM of 14 and 16, then the LCM will be 2 to the power 4 into 3 into 7, like that. Okay. Now this is just for example purposes. So this is how you have to find the LCM and HCF. And one more thing you need to remember is while writing the HCF and LCM or writing the prime factors, you need not need to write them complete like 2 into 2 into 2. If there is multiple repetitions like 2 has occurred 4 times, then you will write 2 to the power 4, or here in the case of 12, 2 to the power square into 3, right? So this was the basic thing that you need to remember for HCF and LCM using prime factorization method. Now there's one more thing that is really important and questions are asked on this one. Now I will do it with a red pen. Okay, so note, this is a note point. Okay, HCF, in your NCERT book there's a question in which they have given numbers like this, like HCF bracket some random number xyz, let's take it a and b, into LCM a comma b is equal to a into b, like this it is. This is the general formula. Now if in the question they have given the value here, if they're given some xyz value, then need not to fear, because this value is actually the product of these two, right? So if they have given any value, just take it to the LCM side, sorry, to the RHS side. And if they have given HCF, suppose 9, and this number A and B some 2 and 4, then 2 fours are 8, and then you need to shift 9 to other side, so it will be into division, so 8 upon 9, like that. Okay, so let's begin with method for finding irrationality of numbers. So this is really simple, but the soul and heart of real numbers. This is the reason why you're learning real numbers. Okay, and most of the questions will be asked from this only, finding the irrationality of numbers. Now, how we will find the irrationality of numbers? So there's a method for doing that. So first of all, there's a statement that you guys need to write in your books. That is, we know that a number is an irrational number. Irrational number if it cannot be written or expressed in the form p by q, where p and q are integers and q is not equal to 0. In fact, for any number p comma root p is an irrational number. Okay, to prove the irrationality of a number, we use the contradiction method. Okay, now this contradiction method is really important. This one, wait, this is the contradiction method. This is really important because you need to write it in your answers as well through contradiction method, like that. So now let's solve an example. Okay, by solving an example you will understand better. So there are actually three types of subtypes in finding the irrationality of numbers. Actually not the method, but the type of question that they will ask. Okay, now the really basic will be finding the irrationality, root 2, find whether root 2 is an irrational number. Root 2 is an irrational number. Okay, so first we need to write, let us wait, I will write the solution in blue. Okay, solution, let us assume root 2 to be a rational number. Okay, sorry, yes, root 2 to be an irrational number. So here in the next step you will write root 2 is equal to p by q and bracket. So now this step that you're going to write here is really important. Without this step you will lose marks. Okay, so I will write this one as extremely important star. Okay, now write where p and q are co-prime integers and q not equal to 0. This is a statement that you have to write. Now I will explain you what is a coprime. Okay, coprime is a number or a set of numbers which have a common factor 1 or the number itself. Only 1 or the number itself. Wait, sorry. It won't be the number itself. They have the common factor only 1. Suppose there are two numbers, so their common factor should be 1 only. Those numbers are called coprime numbers. Or you can also say that HCF of those numbers is only 1. Right? Let me write it. HCF of coprime is equal to 1. Okay. Now let's get back to our topic. So root 2 is equal to p by q, where p and q are coprime integers and q is not equal to 0. This statement is really important. Okay. So now what we'll do here is shift q to this side to LHS. So it will be root 2 q equal to p. Okay. So draw a box over here if you can. So it will be highlighted to the examiner who will check your paper. Now what we will do is square on both the sides. So 2 q square equal to p square, and write in the bracket squaring on both sides. Now whatever you're doing, whatever additional steps you're doing or any steps that are required for you to solve the question completely, write them in bracket. Tell the examiner that you have done all these steps. Okay, only then they will correct your answers. If you do it like you do in 9th standard or 8th standard, then they won't give you marks. In CBSE board examinations, you need to clarify each and every step that you do on the paper. Okay, so after doing this, you can write 2q, wait, 2 divided by p square. So wait, it should be, so now you will write 2 divided by 2q square. Now, as you know, as we have proven here, okay, wait, this step won't be required. Okay, only this one is important. The one that I am highlighting with the red pen, this step is important. Okay, so now after doing this, 2 divides 2q square, right? And now in the above that I have highlighted in the red pen, 2q square is equal to p square, right? So 2 divides p square, and as we have seen in the theorem, if a square is divided by any number, it also divides non-square. Okay, suppose 2 divides p square, so it will also divide p. So we have found out that 2 is also a common factor of p. Now in the next step, let's take p equal to 2k, k being any positive integer. Okay, now you need to square on both the sides. So p square is equal to 4k square, squaring on both sides. Okay, so now we have found out p square is equal to 4k k square. Now if we look at here, we need to take this red box equation that we have already done over here. I will start this one. Okay, this one over here. We need to use this again. Now we have taken p is equal to 2k as a new value. So 2q square equal to 4k square. Right. Now we'll shift 2 to RHS. Okay. Shifting to RHS, we will get q square equal to 2k square. Right. Now we will divide. That means q square, sorry, it should be 2 divides 2k square. Actually now we have found out another equation. This one I'm doing with star. This is another equation that you need to remember. So q square equal to 2k square. Now in the below step we have done 2 divides 2k square. But actually what it will do, 2 divides q square. See, 2 divides 2 divides q square. So if it divides the square of a number, then 2 will also divide that number, right? This is what we need to find. Now the final statement, which is really important. Okay, as we can, sorry, this implies that 2 is a common factor of p and q. Hence this contradicts our assumption. Therefore root 2 is an irrational number. So here you have the proof, and now if you really want to like elaborate and write each and everything, you can write hence proved. Okay, now this is the complete equation, the complete question you need to solve in your exam, and if you miss even a smallest step and make any errors, then the whole question will get completely destroyed. The whole question will be wrong. Okay, so be very careful and very calm while doing this question, because this question is asked for 3 marks. Okay, asked for 3 marks. Okay, remember this. And also the question that I just took as an example, this one is actually asked in the CBSE board exams. Okay, let me tell you. CBSE 2023 standard. It was asked in 19, 10, 9 and 8. Okay, so remember this, that this is a really important question. Okay, so this is it for today guys. I hope you enjoyed my video and learned something from it, and I will get back to you in the next lecture, in which I will show you some different examples in which the questions can be framed in this in the proving the irrationality of numbers. So this is it for today. I hope you enjoyed my lecture, and see you in the next lecture.